All right, at this point, we're going to work through 5 problems involving factoring and solving quadratic equations. If you are working at home, I will pause and give you an opportunity to press pause so that you can work the problem, and then you can hit play when you're done, and I'll give you the answer. All right, so if you're going to work it at home, that'll be a good time to pause. So for this, here's what you have to know. That if there's, the first thing you got to do, all right, to kind of have a global conversation about factoring, is you must count the number of terms. All right, that's the first thing you got to do. You must count the number of terms. So the only ones you ever deal with, and the only ones you'll deal with on a test will either be 2 terms, 3 terms, or 4 terms. You never have anything more than 4. You never have anything less than 2. And by the way, if you had less than 2, it wouldn't even be a factoring problem. So those are the 3 that you deal with. And every time you have 4 terms, we're going to factor by grouping. Every time we have 4 terms, we're going to factor by grouping. All right. So as we look at this problem, we realize that this has 4 terms. All right. Now, when I factor by grouping, I just split it down the middle. Okay? But pay attention to what this sign here is. Pay attention to that sign. If that sign's a minus, we're going to want to factor out a negative, and it's going to change the last sign on the end. All right? If it's positive, we just leave it the way it is. So here, I'm factoring these 2 pieces, and then I'm going to factor these 2 pieces. To do these 2 pieces, and I'm sorry you can't see that I'm pointing, to do these 2 pieces here, the x cubed is common to both. And then what I have left is x plus 2. Okay? Now, when I take out the 27 here, the 27 is common to both. I'll be left with x plus 2. Now, one of the things I think I've told you is, kind of as a student, I didn't really take notes a whole lot, but what I really focused in on was, when I'm done, what does the answer look like? Right? When I'm done, what does it look like? I know that if I've done this correctly, this and this should probably be the same. And if they're not, then somebody has made a mistake. It might be me. It might be you. Now, some teachers are kind of like a-holes. And they go like this. If there's a mistake, it's probably you. I don't know that. Okay? I've done it before on a test where a student came up to me and was like, I know that these parentheses are supposed to be the same. And I looked at it and I went, dear God, they're supposed to be, but they're not. And then I felt like a real jerk because the answer was prime because it wouldn't factor. And, and I've done it in class before where we do it and it doesn't work, right? They should. If I've done my job, they should be the same. Okay? So, double check your work, but don't fret over it if it's not the same, I guess is my point. Okay? Because it may be a mistake. All right? If we take the x plus 2 out, what are we left with? X cubed plus 27. Okay? Now, when we have a binomial and the exponent is not 1, everybody knows when they say a red flag goes up. If the I just clicked on red. If the exponent's not 1, a red flag needs to go up. If the exponent's not 1, a red flag should go up. Because oftentimes, when it's not 1, I've done it on purpose in such a way that you can factor again. Here's the problem. I don't know how many of you are familiar with ATM machines. Not ATM machines, slot machines. You ever played a slot machine? Anybody ever played a slot machine? You have, for real?
I was very little because my dad took me to
Oh, wow. We just start you young. Honey, we're going to go gamble. Let's go. Daddy, I'm only 7. Drink some whiskey.
I was about that age.
Here's the interesting thing. Slot machines work off this principle of you never know when, but it's going to happen. That's kind of the idea, right? You keep playing because you go like this. I don't know when I'm going to win, but I think I'm going to. This is going to factor probably 7 out of 10 times. Does that make sense? You're going to get an exponent that's not 1, and that's going to factor again 7 out of 10 times. The problem is you got to be able to decipher the 7 from the 3, right? This continues. This is the sum of 2 cubes, and therefore you have to continue this out. This piece stays the same, but then this piece becomes x plus 3, and then remember it's x times x is x squared, 3 times x is 3x, 3 times 3 is 9. All right. X plus 2, x plus 3, and then x squared minus 3x plus 9. 27 is 3 times 3 times 3. Okay? And that's why you use the x and the 3. We're using plus because this sign is plus. Does that make sense? Okay. Now, I don't know how to tell you this. This kind of problem is on the test. Okay, in some form or another, it's going to be on there. All right. One of the things that makes the factoring test so hard is that if you don't know how to factor, question 5 and question 6 are almost identical. Does that make sense? Like, and then you're like, oh, well, maybe I can do 7. Nope. Maybe I can do 8. Nope, it's the same as 5. Okay? And then you get down to like problem 20 and you're like, well, damn, they were all the same. And then when you go to the problems involving solving, and what do you got to do? Factor. And so you don't get those right either. Does that make sense? It's so very critical that you're able to factor. All right? That's sums of cubes there. Okay? Now, what if it has 3 terms? What if it has 3 terms? Here's what you're going to do. The first thing you're going to do is, and I should say this, not just here, but everywhere. All right? Everywhere. Look for common factors. Okay? Look for common factors. For those of you that are watching at home, you can't read that because I can't even read it and I just wrote it. Look for common factors. Actually, it's not that bad when I look up there. Look for common factors. All right? If there's 3 terms, if there's 3 terms, ax squared, bxc, or whatever the case may be, the first thing I want you to do is identify that sign. That last sign tells me how these 2 signs will go here. If that last sign is positive, these 2 signs are the same as the middle one. So if it's like x squared plus 8x plus 12, these 2 signs would be plus. If it were x squared minus 7x plus 12, these two signs would then be negative. Does that make sense? That last sign, if it's positive, these two signs in the parentheses will have to be the same, and they will be whatever the sign in the middle is. That's very important to hear. Now, if that last sign is minus, then I know that one of these has to be plus and one of these has to be minus. I will not know for sure which one's which until I've checked it and tried to find out what the middle term is. All right? But I do know that one's got to be plus and one's got to be minus. So I always put them in as plus minus, and then I adjust it at the end if I have to. But to get me started, I'll just do plus minus. And let's be honest, I'm right 50% of the time. Okay? All right. So when we look at three terms, the first thing to look at is this sign here. That sign's plus. So what does that mean about these two? Huh? No. They're the same. It doesn't mean they're plus. It means they're the same, and they're the same as that middle term. So in this case, they're both negative. Let me say that again. We look at that last sign. If that last sign is a positive number, then I know that these two signs in the middle have to be the same. And then they have to be whatever that middle term was. Because you got to get negative 35 when you're done. Does that make sense? Now, what do you do from here? Well, you got to get this number and this number have to multiply to be 12x squared. So you could do 12x and x. You could do 2x and 6x. You could do 3x and 4x. Those are your only options. Do we agree? Now, I choose the numbers closest together because they tend to work more often than not. Okay, please understand what I mean. I'm not guaranteeing you that that will work. Okay, how many of you have at your house right now a dog? Dogs are the worst. Not the worst pet, but they're the worst at it. How many of your dogs will beg you for food? Right? Now, why do they beg you? Because your asses have given them some shit. My dog, every morning, goes outside, comes back in, and then comes to the kitchen and stands next to me. Because I make my daughter a sandwich. It's either pepperoni or turkey. And she knows that there's about an 80% chance that when I get done, I'm going to throw some her way. I want to be the favorite. She likes me better than everybody in the house. Okay? I give her pepperoni and turkey about 80% of the time. So here's what she knows. It doesn't always work, but there's a good chance. Does that make sense? Like, it ain't guaranteed. Because, like the other day, I ran out of pepperoni, and she looked at me, and I'm like, baby, I am so sorry, but we don't have more pepperoni. We done. And then it's like this moment of like, off to the kennel she goes. And then I felt guilty, and I thought about buying her some like hamburgers on the way home, but she's a dog. All right. Take the numbers closest together. They tend to work more often than not. Not saying it's guaranteed. I'm just saying if you got to make a guess that. So we're going to plug in 4x and 3x. Okay. Realizing that if 4x and 3x don't work, we'll try 2 and 6 next because we want to take the numbers closest together. Okay. Now I got to plug in numbers for 18. Which ones are closest together? Three and 6, 9 and 2, 1 and 18. Okay. if you don't know your multiplication tables very well, there's apps for that. And I'm not even trying to be a jerk. I'm being serious. There's apps for that. Please learn them because it helps you factor. Do you realize that 3 and 6 cannot work? Why doesn't it work? You said you realize it. Why doesn't it work?
Because they have similar numbers.
Right. So where are you putting the 6 at? If you're going to put a 6 in here, where are you going to put it? Well, you ain't got but two choices. Either you got to put a 6 there or you got to put the 6 over there. One or the other. If you put the 6 here, that's a common factor. Can't do that. If you put the 6 here, there's a common factor. And somebody told me a couple semesters ago, there ain't no common factor. What do you mean there's no 4 don't go into 6? I didn't say 4 go into 6. I said that there's a common factor between 4 and 6, and that number's 2. So 3 and 6 aren't going to work. Newsflash, 2 and 6 won't work either. If you changed it from 4 and 3 to 2 and 6, hell, that ain't working either. So instead of using 3 and 6, what should we try? What should be our first choice? 2 and 9. Does that make sense? Now, where am I going to put the 9 at? You ain't got but two choices. You either got to put it here. You either put it in A or you put it in B. Where's the 9 going to go? Why? 4 and 9 doesn't have any common factors. 3 and 9 do. So you can't put the 9 over there. So this is a 2. Now we check to see if it works. Negative 27x minus 8x is negative 35x. And that does indeed work. Does everybody see the way that works? Starts off by you got to know your multiplication tables. Okay? Number 2, make sure you're not putting common factors side by side. See, back in the day, your teacher who may or may not have been very good, the more I tutor high school kids, the more I hear horror stories of what their teachers are like. You were just plugging in numbers and just checking randomly. I mean, you were plugging in crap that had no chance of working, but you didn't know that it had no chance of working. You were just getting pissed off that it didn't work. No, it's the truth. I mean, you know, you put a number in there and then you check it and then you're like, oh, that number don't work. Erase that one. Let's try another one. 1 and 18. Nope, that don't work. You didn't notice that 3 and 18 had common factors and you shouldn't even be trying that anyway. You didn't know it didn't work till the very end. And then you erase that. And then at some point you just get pissed off and you want to quit. At least I would. Okay? Please. That's how that works. We good on that? Now, if there are two terms, that's got to be either the difference of two squares or the sum difference of two cubes. Now, we've already talked about cubes, right? That was the first one we did. This one is the difference of two squares. X to the 4th is a perfect square. 81 is a perfect square. Does that make sense? So x to the 4th is x squared plus 9. X squared minus 9. Now remember, if the exponent is not 1, a red flag needs to go up. The exponent here is not 1. The exponent here is not 1. Hello, major red flag. Yes, that's when you kind of have to subdivide it, right? So what happens here is that, oh shit, what the hell I just did? Shoot. For those of you who are listening at home, that was shoot. Parents, I love you. I don't care what your kids say about you. All right. X squared plus 9, that does not continue. That just stays the way it is. All right. All right. X squared minus 9 is the difference of two squares. Don't force this. Don't force that. I see a lot of people who force x squared plus 9. You know what I mean? I asked my son to put away to do something for me. He had to do a screw thing. He had to screw something in. I said, did the screw go in? He goes, not at first. What the hell do you mean not at first? He's like, well, I had to screw it kind of, but it eventually went in. Y'all, that screw ain't ever coming back out of there. I'm like, dude, if it didn't fit, you're not supposed to do it. He's like, oh, I just forced it. Please don't force it. Don't force this. Okay, don't force this. Plus 9 doesn't work. Minus 9 does. And people will ask me, well, why does the minus 9 work and the plus 9 doesn't? The minus works because when you distribute this out, this is plus 3x, this is minus 3x. These will cancel. The plus won't work because if you do x plus 3, there's nothing that forces that middle term to cancel. And people will say, well, then change it to a minus. Well, if you change it to a minus, you're changing it from positive 9 to negative 9. Does that make sense? So hence, you can't do the plus. Unless it's a cube, and then you can. Which is kind of where people say, why do you keep changing the rules? If it's a plus, you can't do it, but if it's a cube, you can do it. Yeah, there's some rules to that. All right, number 4. How do we solve? If I have 2 parentheses equal to 0, how do I solve? All you want to do is take each one of those 2 pieces and set it equal to 0. Just solve them independently. Now, why is that? That's because if 2 numbers multiply to give you 0, one of them had better be 0. Does that make sense? Like, if one of them is 6, the other one can't be 7. Because if it is, you ain't getting 0. If one number is 6, the other one has to be 0. Does that make sense? All right, so in order to solve this, we set each piece equal to 0. We get 2x equals negative 5. Divide by 2, so x is negative 5 halves, and x is 3. That we get 2 answers for. That we get 2 answers for. Okay. All right. Lastly, if it's like this, how do we solve it? We solve it by factoring. We got 2x plus 5, x minus 3. That's 5x. This is minus 6x equals 0. And that is the exact same problem we just worked. X equals 3 and x equals negative 5 halves. Some of y'all going like this, you damn tricked us. Yeah, I did. Okay. I'm going to stop the video here. This video was brought to you by Burger King. You can have it your way.